thanks guys for being here and for watching if you are connected on our YouTube channel. This is the second issue of the Zerynth Continuous Learning web series. Last one we talked about microservices and orchestration, and thanks Davide, our head of software engineering, for the talk. And today we talk about UX design, user experience design for IoT. Thanks to Daniele, our CIO, and thank you.
Thank you guys. Let's start with an introduction that most of you should have already seen. This is the Silicon Valley TV series. This is the launch of the Piper product. You will not hear the audio, but doesn't matter. This is the launching day. Everything is super exciting. I mean, the first day you launch a product on the market, you typically take a picture, everything is ready, you spend a lot of time implementing amazing stuff, and then you expect to have tons of users waiting for your release, because you invested so much time in developing this software, though this is pretty obvious that there are so many people waiting for this out of there. And you selected all the most amazing features available on the web, integrating the last rocket science technology in the development of this product, but no one is using them. And this can happen. And this is mainly due to a very simple reason. No one was asking for that features. Okay? You were probably the only one interested in integrating that amazing technology because you are the only one in love for the technology. All the rest of the world doesn't care about technology. Okay? And of course, in Silicon Valley, they are a very good team, they have good friends, and if you want to know how they reach this peak, you should see the rest of the series. I don't want to spoil it. So, today I'm going to talk about user experience. And user experience for Internet of Things, we do Internet of Things product, and we do connected product. But I mean, there is an important footnote. 90% of this presentation is about user experience, because you have to know what the user experience means, user experience design means, in order to understand what UX for IoT is. Can we see now the video? The screen? Okay. There is a very famous quote for Alan Cooper, that is the father of Visual Basic. I know what you think about Visual Basic, doesn't matter. He's a very good computer scientist. That say, if you want your user to like our software, we should design it to behave like a likable person, respectful, generous, and helpful. What does it mean? It means that your software is something that had to be designed in order to allow a playful, pleasure, and a lovable interaction. Okay? Why? In particular, in our case, that we develop software that are, what you say, for business. I mean, for other developer, you have to consider that your peer, so the other on the other side, the user on the other side of the monitor, is using this software for work. It means that people are spending something like 8 hours per day in front of your software, if you are lucky. Okay? Why they should spend this time with something they hate? Also, if it is based in the most amazing technology. Okay, so first of all, it's a matter of pleasure in using the software. What I'm going to talk today is based on the seminal book and the seminal work of Donald Norman. This is a professor from US that wrote this seminal book that is called The Design of Everyday Things. Okay? In Italian is La caffettiera del masochista. You can find both the book in Italian and in English. Moreover, if you want to have more information about this word, you have these two links you can have a look. In particular, the usability.gov is organized as a sort of collection of different articles, very well organized among the different topics of user experience. So they are very interesting guidelines for going in more detail. Okay, let's start with the definition. What a user experience designer is. The UX designer is the one that is in charge for the designing of the experience of the user while using your software. So the UX designer takes care of how a product behaves during the use. Very important. UX design is a complete user-centric design approach. So you can't design the user experience without focusing everything on the user. This seems obvious, but it's not in the practical meaning. And most important, you can't design the user experience. You have to design for the user experience. What does it mean? You can't pretend your user to behave as you design it. You have to design a software that drives your user in the correct behavior. You can't force your user in doing what you expected. You have to drive your user in the correct path. What's the difference between user interface design and user experience design? User experience doesn't care about graphics, doesn't care about layout, doesn't take into consideration any color, schema, HTML, CSS, and whatever. User experience cares about, again, the behavior of the user while interacting with the software. The output of the UX design process is the input of the UI design process. UX designers are producing guidelines that will become the requirement for the UI design. Okay? In the real application of this, you have a typical lean approach where you have the classic cycle of ideate, implement, test, evaluate, and again. So it's not a straightforward line where you have the UX designer that developed the guideline, then he goes working in another company, and the UI designer are taking that guideline and implementing. Of course, there is a continuous feedback loop. So the core of a technology should be focused on the interaction design. You have to think what will happen to your user while interacting with your software. In order to do this, you need to design the visual aspect. You have to do research in order to understand which is your user base and how it behaves, they behave. Then you have to create tools that allow you to extract information from your user base in order to create the fundamentals element on top of which you will base your user experience design process, and then only later you will develop something. Okay? There are only two ways for building something: good and bad design. There is no halfway, there is no gray. Things aimed at that, at being used by people, can only work well or do not work absolutely. What happened in people's mind while interacting with the technology? only two things can happen: pleasure experience or frustration and irritation. When the UX design process has been done well, we will have a product that brings our user toward a pleasurable experience. So you will feel comfortable in using this product. You will feel well while using this product. Vice versa, wrong design lead to frustration, irritation, and negative mindset toward the use of this software. Why it is important to take this into consideration? Because we have always to remember that human beings are not rational. Okay? And this is something that is very difficult for developer to take into consideration, because developers are a particular species, subspecies of the humankind that develop a special capability, and they shape their mind in order to use more the rational part than the other part. But the rest of the population, of the world population, is not like that. 90% of the people in the world are using more the irrational part, non-rational part of the brain than the mathematical and logical and rational part of the brain. So if you, as a developer, designs something that requires people to act in a rational way, you will fail. Okay? Because you will induce people in working out of their comfort zone. In the lucky case. Because this means that they can at least try to go out of the comfort zone. But most of the people out there are not able to go out of this comfort zone. So people are imaginative and creative. And this is a big problem for you as a developer. Because when you have a user that is inventing solutions for interacting with your software, you are in trouble. Because you have unpredictable experience. You have users that can do fancy stuff while interacting with your software. And you haven't predicted that kind of behavior, because they are far from the rationality you typically base your design process on. Okay? And this is why people consider machines as limited. You have to design for a population of users that are considering the machines as limited. Don't ask your users to see in the machines what you see, what you perceive, like a general purpose tool that allow me to change the world. No, for them, a computer, a tablet, a laptop, a smartphone is like a coffee machine. There is no difference. Tell me which is the button I need to push in order to have my coffee. That's all. But typically, as developer, we say, okay, the user are not behaving using my software in the correct way. It will be simple. They should read the manual. Or it is so easy, but they are not understanding. We should stop blaming the user and start blaming ourselves as a designer. This is the most complicated mindset change, mindset switch, if you want to become a developer able to develop useful and pleasurable software. What does it mean? That we have to invert this paradigm and start to accept that every user failure is our failure. If the user is failing in interacting, it's because we failed in the design. Okay? Your design should avoid not expected user behavior. This means that you have to stop designing product for your similarities. And you have to start taking into consideration as either high-level user your grandmother. Design everything for your grandmother, not for your peer or student. And typically, when you start discussing with designer about this, someone could say, "Wow, come on, we are humans, so we should be able to design for us. If we are humans and we are using this software, why other humans are not able to design this software? You are not humans, you are programmers. Okay? And you are a tiny percentage of humanity with very strange attitudes. Okay? Moreover, always remember that life is made of experience. Donald Norman interviewed in an automotive company, and they were asking. Yeah. And he asked employees of this company to what they thought about experience in the user machine interaction. They say, "Oh, we are engineers. We don't like this experience. We like requirements. We like technical description." And then they say, "Oh, can you tell me? Can you describe me your car?" And some of them reply with this sentence. So everything you try to describe is based on the experience you have done while interacting with that system. So also if you think to be super rational, also if you think to be unable to feel any kind of emotion, your brain is not able to store in its hard drive any event without collecting information on the basis of the experience you have had. So it doesn't mean that at the end of your working day you will bring home from the interaction you have had with a specific software the experience, not the result. The experience means only being proud of having developed that algorithm by the end of the day. Probably you will not remember the detail of the algorithm, the commas or the number of brackets and the number of line of code, but the results, how you felt when finally you obtained the solution. So the way we think, the way we remember is based on experience. So this is the trick for having happy users. Inducing in them pleasurable experiences. If the kind of experience you have are positive, you will have an higher aptitude in continuing to use that software. And always remember that for a company that is doing software as a service, one of the most important things is customer retention. Customer retention is based on this stuff. Avoiding having sad user, unhappy user, frustrated user. Cognition and emotion are tightly interweaved in our brain. What does it mean? That a frustrated user will not be able to do the correct action. What I mean, if you are frustrated, your mind will go in a condition that prevents you to act rationally. So, if you are very upset, you lose mathematical capabilities. So, we have to reverse the typical paradigm. It's useless to try to give super cool feature to a user without taking into consideration her or his emotion while using the software. Because her will not be able to perceive this super cool mathematical or technical feature you gave them if they are not in the correct mindset. And the fastest approach you have to bring them in a positive mindset that will be oriented to the use of the feature you are developing for them is to make them happy. Okay? Like today, bringing cookies, for example. There are some fundamental principles we can try to follow for going toward a good design, or at least avoiding bad design. And all these principles has been, let's say, identified by Norman in the Design of Everyday Things book. First of all, a good design is based on two main principles: discoverability and understanding. Discoverability is the property of a software or any kind of interface to tell the user what is possible to do and how. Okay? This is one of the most hated things ever invented by humankind, because every producer of this stuff places the sensor in different position with different time for the activation. So when you go in a typical, public space toilet, there are people doing fancy stuff and trying to wash their hands. Okay? It's because our knowledge base about this object is far from the kind of use that this new generation of tasks are pretending, and so we feel frustrated in interacting with these devices because they are less discoverable than the typical similar category object we have in our houses. This gap, we will see better later, brings us to frustration and fancy dancing. Another problem is understanding. So, the terms can be misleading, but try to follow me. You discovered how to use this stuff and what you can do with this device. But you haven't yet understood the dynamics of how the system works. Typical example, stoves. Okay, how many times you try 2 or 3 knobs before understanding which will be the fire that will be started? More or less every day, 2 times per day. If you cook 2 times per day, you do at least 1 error. Okay? It's because, we will see later, this subset is not mapped correctly on this other subset. So your brain has no idea how to link a control with an effector. If you change in this way, there is no space for error. Okay? So this solution is easier to be understood than this one. Norman lists 6 fundamental principles for the design of object aimed at interacting with people. That is one, and we are going to see in detail each one. The most fancy one are affordances. Very important. Affordances are not properties, but are relationships. What does it mean? An affordance is a relationship between a property of an object and the capability of a user. A chair affords for a normal developing human being, I mean not completely normal, but I mean for sitting. Okay? But can also afford for standing. Okay? It can't afford for, I don't know, holding a bottle down. Okay? But if you are a tiny child, 1 year old, this chair doesn't afford for sitting anymore. Because you are not able to walk on top of it and sitting on it. So it's a relationship. Affordances are relative and depends by the couple, okay, by the joining of these two properties. So, for example, in your word, smartphone. If the smartphone is on and you are not wearing any insulated gloves, the entire screen affords for the touching. Okay? But this doesn't mean that touching in any position brings you to an action, an event, to comport any reaction of the system. The signifiers are the indicator of what and where you can do some action. So, this signifier means that you can touch and slide to one loop. So, the property of being touchable, in this case the affordance, is available on the entire screen. But in this position, thanks to this signifier, becomes a control. Okay? As we saw before, for the understanding, another fundamental element for the design of interactive system is the mapping. Okay? Mapping, also in the computer science, is the relationship between two subsets. Two sets. These sets typically are control and effector. We want to map some controls on some effects, that in our case in computer science are functions. This link should be easy to understand by our user without assuming any previous knowledge. So, which is the easiest way for doing this? Using natural mapping. And our brain is very good in doing the memory. Do you remember the memory where we were child, children playing with mapping the similar objects, similar shapes and whatever? Okay, we are very good in that. So use this trick in order to leverage on natural mapping. Be careful, sometimes what you should consider a natural mapping is not natural worldwide. Like, for example, top left has starting point of the reading, so the menu button typically placed on the top left. In all that cultures where they wrote from right to the left, this is not true anymore. The starting point is not top left, but is top right. This is just an example. Okay? There is an interesting reading if you wanna do. You should Google why Mac and Windows are using two different scrolling directions. Have you seen that? iOS and Windows scroll in different directions. It's because the mapping they use for developing that kind of interaction is completely different. Feedback. The feedback, you know what it is the information that the system provides to you in order to make you aware that your input has been received. Okay? Feedback are fundamental, are one of the most powerful way for improving the usability of a system. But they are also very dangerous. Okay? First of all, because they need to be immediate. If the feedback happens more than 10 milliseconds after the user action, the brain is not able to correctly map the feedback with the provided action. It means that the user could map that event not as a feedback of the previous done action, but as something different. And this should start us thinking about the Internet of Things. We can not always rely on a remote connection availability. So, implementing a feedback, a usable feedback in the Internet of Things world is very challenging because of this reason. Moreover, feedback must be informative. Pushing a button and receiving a red light, and then pushing another button and receiving another red light doesn't mean nothing. Implementing a system that every time you push a button turns on an LED in red is completely useless. Implementing a system that every time you push a key button on a keyboard play a beat could be useless, depending on the kind of application. Okay? So you have to seriously think which is the information I'm gonna provide to my user thanks to this feedback. If you are not able to answer this question, remove the feedback. Okay? Because every new stimulus you will provide to your user will cost the user energy, computational energy, in understanding that stimulus. So if this stimulus is not helpful, like in this case is not a correct design and feedback, you should avoid the implementation of that feedback. Poor feedback can be worse than no feedback at all, because users will start to try to understand what that stimulus means, and their attention will be driven away from the real interaction, and will be focused more on the implementation, on the understanding of the feedback than on the interaction itself. Now, the most complicated things for a developer, and also the core of user experience in software, the conceptual model. The conceptual model is the explanation, usually super simplified, of your system, of how your system works. The most famous conceptual model is the folder organization in our computer. You know, there are no folders in our computer. Our hard drive is not divided in folders. There is no concept of folder in the file system. That are there. But computer graphic interface designer, and also command line interface designer, selected the most obvious conceptual model for the organization of information, a library. A library is composed of rooms, shelves, folders, books, and file. File is a page. That conceptual model was there. So while some developers were thinking how to store bits in an hard drive or in a magnetic tape, some others were thinking how we represent this for common people, that they don't have any idea of what a bit is, and they are not interested in learning what a bit is. So this is the conceptual model. The problem is that simplified models are valuable only as long as the assumptions that support them hold true. What does it mean? If the extreme simplification you are going to do of the of your system does not correctly represent the reality, you are in trouble, because your user will follow that model, will internalize that model. So at a certain point, the user will not be able anymore to use your system because he's expecting your system to act in a different way, because his interaction is based on a wrong model. The typical example are the cloud storage systems. Okay? You open your file explorer, OneDrive, Dropbox, and if you haven't, this is true in OneDrive for example, if you haven't selected the option available offline, you have the folder there with a tiny different icon in terms of color. You click in the folder and the folder opens. Then you click on the file and the file is not available. This means that this new system, cloud storage, has extended the conceptual model of the data storage represented as folders without taking into consideration that offline the model is not able to represent, that simplified conceptual model is not able to represent the reality. Because have you ever seen an offline library? Have you ever been in an offline library where books are there but not there? They are just represented there as a shape in different color, but they are not there. They could be there if they put online the library. Okay, for you everything, I mean, probably you feel this as obvious, but do you remember? We are designing for our grandmother. Mental model is the conceptual model internalized by the user. So you develop the conceptual model as designer. I will develop a mental model of that system. On that, if we are lucky and very good designers, UX designer, they fit. It means that as much is bigger the difference between the conceptual model and the metal model, as lower will be the user capability of using the system. As closest they are, as higher there will be the experience and the user capability. Okay? The point is that different people and different users can create different mental models starting from the same conceptual model, because the mapping depends on the knowledge base. So on what you already know, that is what you use for interpreting the model I designed, creating your own idea. The mix of all the elements you provide to the user for creating the mental model is called system image. And why the system image is important? Because when your system or product leave the company, the product can't rely anymore on its developer or designer for being described to the user. So you have to provide the user with other sources of information that allow the user to create the mental model. So the shape of the device, of the system, the layout of the interface, the user manual, the post blogs, the community forum, the spot on the TV, the advertisement and whatever, everything comport the knowledge transfer from us as a company to our user, and this drives the creation of the mental model. The set of all this information is called system image. And Norman poses this element at the vertex of a triangle that I will prefer represented in this way. Because what is important in this picture are the algorithms. Here you have only one chance. When the product leaves the door of the company, that's all. You decided to put 1, 2, 3, 4, 5 buttons because you designed a conceptual model for that functionality, that's all. You can't add a button. You can't remove a button anymore. The conceptual model is fixed inside the product. It's almost impossible to change a conceptual model after the product has been released. It's a bit easier with the software, but you typically change the version. So it is Windows 10, Windows 8, Windows 7. You remember that stuff? That's changing the conceptual model. Moving the window bar from top left with the square button to nowhere and then waiting for hated people and reinsert the bar. That's changing the conceptual model, okay?
Or removing Cortana.
Or removing Cortana from the bottom. That's exactly what does it mean. Big problem with the super big. This is not true in the relationship between the user and the system image. Why I'm telling you this? Because blogs, advertisement, updated user manual can help you a lot. Because are things that you can update, that you are in charge for updating also after the product release. Are you following me? You can't change this anymore, but you can publish how many blog posts and tutorials you want in order to fix problem that you have introduced, maybe in the conceptual model. Okay? This is why community management is very important nowadays. Okay. Until now, we saw how we should develop interfaces and system aimed at interfacing with people. But why? Now we will do a brief analysis of how people do things, how people think while interacting with objects. Norman defines the interaction between a user and an object with two goals: the goal of execution and the goal of evaluation. The goal of execution is when the user, given some intention, imagine which action she should perform, then apply these actions as input to the device, and then receive a feedback. Interpret the feedback, evaluate the feedback in order to understand which is the difference between the expected intention, the goal, and the obtained results. Okay? This is the interaction loop described by Noam. Now, let's imagine that these gulfs can be stretched. And as deeper they are, as most complicated the interaction is. As much effort you have to spend for defining the intention, defining the action, and providing an input, as more complicated your interaction will be. Because of a not well designed execution, gulf of execution. Vice versa, as much complicated will be to evaluate what happened, as much complicated the entire interaction will be. The role of the designer is to create bridges between these two gulfs. As straighter the experience, it will be, as happier, as lovable the interaction with the system will be. Okay? This is where you have to work. And these are the 7 states of actions: goal definition, intention, action specification, input performing, information collection, interpretation, evaluation. Every time you add a button, you should try to imagine what your user will do across this journey in each of these 7 steps, because all these steps will happen every time you click a button or a mouse pointer in a specific point of the screen. If you don't take into consideration these aspects, you will have user frustrated, and typically the user will think, oh, this interface is too complicated for me. Or, wow, I am stupid. In both these cases, first of all, he, she is wrong. We are the stupid as designer and not our user. But most important, we will be in trouble, because a user that will go in that mindset is very difficult to maintain as an active user. Because in this kind of frustration, typically a user will live. And it's very, very, very complicated to convince him or her to go back and try again. Okay, until now I mentioned it many and many times, the word user. The point is how you profile your user, what a user is. In the UX design, there are techniques and steps for defining your user base. The most powerful element of a UX design process is the definition, step, not element, is the definition of the user personas. Personas are archetypes that represent a subset of your user base. Are extremely simplified characters that you could identify as a category, subgroup of your user base. Okay? The definition of the user personas, is the first step of the UX design process and is mandatory for the identification of the target. Stop developing software for no one. You have to have fixed in mind which is your user. But you will not have one user, you will have various typologies, categories of users These typologies and categories are called personas. How many personas you develop? Very simple. You use the Pareto's law. Pareto's law says that 20% of the causes comport 80% of the results. Again, in another way, represent that 20% of your user base that will bring 80% of your business. Okay? At these links you can find very interesting example of what does it mean writing a personas with sketches, different templates, and you can follow for the definition of different personas. User stories. User stories are what personas want to do with my software. Each category of user will have different need and goal. The user story is a way for describing which are the need and the goal for a specific persona. There is at least one user story per persona. If you are not able to write a user story for a persona, it means that that persona is not usable. There is no reason for taking care of someone that is not using your software because there has no need for using that software. Vice versa, if you are having one user story that fits more than one persona, you created too many personas. Because it means that you created two categories of users that are having the same goal. And goal are the main driver of the definition of the user base and of the software features. Clear? Very important for computer scientists. A user story is a requirement expressed from the perspective of an end user goal. In other way, you define the software feature from the personas. Because thanks to the personas, you can match features with user goals. Clear? Identify the personas. This persona has a goal. In order to achieve this goal, my software has to include these features. Now I have a good reason for the implementation of these features. An example. As a UX manager, John oversees all the design project, including asset creation and prototyping effort. At the design consultancy where he works, he needs easy access to a design tool that allows him to centralize UI libraries so that multiple designers to work simultaneously on a prototype. This is a very extended way of describing a user story. John is the UX manager persona. That's the persona, and here are contained all the need and goal of John. A requirement would be written in this way. The course manager has a requirement to schedule training. If you write the user story, you can derive the requirement. One-to-one for each persona. The template for writing short and helpful user story is this one. Has a role, persona. I want feature because I have a goal. So I need a reason. Okay? This is very important because allow you to match feature that popped out in your mind when you designed the product in your dreamland to someone that really will use. Okay? Who writes the user story? Okay? That's the problem, okay? Because every time we do a course about UX design, they are all super excited until they need to take the pen and start doing this very annoying stuff. Who is in charge for this? The product owner is responsible for having this done. But the product owner is the wrong person for writing the user stories and the personas. And to be honest, there is no good person, because typically the creation of the user stories or the persona is a process that works very well in brainstorming, where all the roles in the company or in the team are flat. You don't care about the role, you don't care about the title. So I suggest that the product owner will lead the creation, the story and the organization of the user stories and the personas, involving all the elements of the team and not necessarily only of a team. But this is a process that works very well in interdisciplinary context. A scenario is an extension of a user story that captures not only what a user wants, but how a user performs the task in order to achieve that goal. Scenarios describe the user motivation on site. So it's not just a matter of a goal, but I have to take care also of the context on which the user acts. An example. A scenario could be the description of how a user buy a ticket while walking, going back home from work, and so using a mobile app. So this scenario is a specific extension of a user story. A worker persona that want to buy a ticket. This leads to a scenario that is on a mobile app because walking on a street, or on a desktop computer while working, or on a ticket desk. 3 scenarios from the same for the same user story: buy a ticket for a worker, for a persona, a worker. Okay? It's an opposite funnel. For each persona, you will have at least one user story, and for each user story, you will have at least one scenario. And then you will have at least one use case. The use case is a task list, is the action list, is the step list of what the user will do, interacting with our system for the implementation of that specific scenario. Why I have more than one use case per scenario? Because, for example, the typical example, I am not already registered, I am not. I want to buy a ticket on this platform. This is a scenario. I'm going to open my app. I'm going to click on the... at a certain point, we have a fork. Is the user registered? Yes, no. This drives to 2 different use cases. Okay? Because the tasks are different, but they belong to the same scenario. Here you find links on example of scenarios and scenarios writing guidelines. The takeaway: you have to stop developing for your imaginary friends. Okay? The user you have in mind doesn't exist because it is you Okay? That's the typical problem of developer. Each developer is in love for his own software. So he's having a very lovable and playful experience with his software or her software. And this is the reason why most of the time the software is not interesting or usable for the other. Because no one loves what we love. Okay? Each one loves strange things. And the strange things are becoming your software. Okay, that's the part that should interest you. These slides are derived from this free book. You can download from here. And the point is, when we try to take all these elements and apply on the design of devices for the Internet of Things works and for connected design, objects in general, we had an order of magnitude of complexity. Because we mix physical shape, industrial design, UE and mobile UE together. Because typically in the web services world, we don't care about the physical shape. We design website and we assume that someone else designed the computer. When you design an Internet of Things device, you merge the two. So at least the conceptual model is one order of magnitude more complex because of the mix of the two. This is, for example, the architecture you can find on the on this Amazon Web Services link of the Roomba cloud control system that iRobot implemented for using AWS system for the control of the robot. You have one robot, one app, and a series of services. Do you agree with me that taking into consideration the user experience of this system is far more complicated than developing a marketplace? Where at least you assume that the user is in front of a monitor, on a tablet or a smartphone or a computer. Here the user could be in the office while the robot brooding at home. The point is this one. We can approach to the design of the user experience of the different parts that compose an IoT system separately. Because this will lead to a misleading experience, to an incoherent experience. But typically the problem is that we organize the software teams in this way. We have software team for the backend, we have software team from the front end, then we have hardware designer, electronic designer, mobile developer, and everyone are working separately, and we are illuding ourselves that we can work by exchanging information via API. This works by the software point of view, but not by the user experience point of view. The user experience of a product should be analyzed in an holistic way, taking all the aspects into consideration. Which are the challenges that we have on top of the typical UX challenges when we go to the development of a connected product? Most complicated one, the specialized nature of IoT devices. What does it mean? This is a general purpose object, guys. A mobile phone is a general purpose object. Okay? When this object is taken by a user, the user goes in a mindset that is, I can do whatever I want. It's very open while using the system. They expect from the system information on how to use the specific app. Because they know that this is just a gate, an interface from the physical to the digital world. This is a general purpose device. It doesn't have any meaning, any functionality like it is right now. Off. This is not true on an Internet of Things device. When you handle an Internet of Things device, you look at the device, and the device, thanks to its affordances, has to convey to you a clear idea of what you can do, for which purpose and how, instantly. Let's imagine a thermostat. On top of this device has to convey to the user a clear strategy, so a clear conceptual model on how this device will bridge the physical and the digital world. It means that the design of the conceptual model of a connected device is far more complex than the one of a web service, because you don't have just to take care of how I represent the files, how I represent the product item on my warehouse. Things are how I represent that your heater is on, how I represent that you can't open the door of your washing machine because the water is still inside, how I represent that I will not start because you haven't done the cleaning cycle. Moreover, typically in the IoT, we have more product that belongs to the same framework. So, an Internet of Things system is a system of systems. And again, here I have one interface for my bank account, one interface, and if I open the website, it will be the same color, more or less the same button. If you have a washing machine and a refrigerator controlled by the same app, in order to optimize the power consumption, you have two physical objects belonging to two very different categories that are connected to the same cloud for achieving the same purpose, saving energy. Conveying the information of correctly scheduling the washing machine in order to do not couple with the high power consumption after dinner of the refrigerator is very complicated. So, until now, we focused all the design processes on the basis of general purpose interfaces. If you want to design good internet connected devices, you have to go back and start taking into consideration how the physical shape influences the use of a device, because you are going to work with physical devices. Moreover, if you want to develop a website, you can take Google Material Design Guideline, any other kind of a guideline. There is no guideline for doing a thermostat, a physical thermostat. You can invent the thermostat whatever you want. No one spent years in defining which is the best color for a website background. So this is why it's more complicated. You have no guideline, you have no reference. Moreover, there are devices that do not have interface. like a smart relay. You buy a smart relay, you plug the relay inside of a box in your electric system. You don't see that device anymore, but that device provides functionality to you. You don't have access to that device. It's not possible to interact directly with that device, and you don't see anymore that device. You have to forget the device while obtaining results from the functionality of this device. You have to induce your user to forget something while still conveying to the user the result of the presence of that stuff. Amazing. Never happened with this stuff. If you don't have the mobile, you will not open the bank account. But I am pretending right now that my heater at home is working right now. The most complicated things in conveying the correct conceptual model is the missing link between physical action and physical results. When you click on an interface in your computer, if nothing happens, it is broken. Okay, you reboot. If you are on Windows, you reboot. If nothing happens. If nothing happens on an Internet of Things device, it doesn't necessarily mean that it's not working properly. Because maybe the correct way for working is to do not actuate in that specific way. So it means that you have to provide feedbacks that are super informative. It's not just a matter of highlighting where you push on a screen. And then the master of all the problems. You don't have Control Z. Undo is not available on the physical world. I put this picture for you. Do you know why? Who think that it's still possible to stop the washing cycle? Is it possible in your washing machine to stop the washing cycle? Yes, it is.
Yes.
Raise your hand. It is. Does it mean that we have the undo? No, because they are partially washed. So you are changing the physical status of something. There is no undo. If you put in that washing machine the t-shirt you want to wear now, and you start the cycle, then you stop the cycle, you can't wear anymore that t-shirt because it's wet. If you type the wrong sentence on an editor, you can Control Z down many times. You press the wrong character, and you are exactly at the starting point. This means that you have to take all this stuff into consideration during the design process, because you have to drive your user in a behavior that cannot take into consideration a step back. Okay, the most important part in the design of the user experience for for connected devices is what is called interusability. The interusability is the property of having the same conceptual model distributed among all the user interfaces. Okay? And this is not obvious. One of the best examples is this one. Google Nest. You have in the hub exactly the same experience that you have in the physical object. So the way for setting the temperature is exactly the same. Here you turn the knob and you have two lines that are showing you which is the current temperature, which is the new temperature, and which is the span you are going to add or subtract. You can do the same there by touching in a point and driving and dragging the lines. But because typically in smartphones people are not, because it's not typical to drag like that, but typically you push the button, plus and minus. They also added the arrows. And the arrows are not available here. But if you push the arrow, the lines will move. Because the conceptual model is driven by the physical object. But they have to give to the user something that is friendly to be understood in the smartphone world, plus minus. In order to support the user in the creation of the correct mental model, while pushing up or up and down arrow, I move the lines exactly in the same way as if you will drag that lines. This will drive you on the future interaction toward the use of the dragging. Are you following me? How complex is taking into consideration the learning curve of someone that will install the nest and in front of the nest will push the button looking at the monitor of the nest for understanding how fast it will update. This will be the typical experience. Okay? And you have to take this into consideration in an overall way. So the trick is to try to integrate all the elements in an overall experience. So all the single interfaces, all the single functionality, all the features of the system should be analyzed as distributed among all the interfaces. If some interface is not able to provide that kind of interaction, we have to take this into consideration in the design of the conceptual model. In order to avoid the user pretending that functionality in that interface. Okay. Another point is that in web and mobile, we have the luxury of assuming that we are online. When you design a website, if the user is on the website, is online until the website exists. If the website goes down, no matter about the user experience, okay? It's not a problem of pushing one button or another. This is not true anymore in the Internet of Things. I can still try to control my washing machine, and my washing machine is not online. How I deal with this? I don't know, but I have to take care of this if I want to design a good user experience for connected devices. Another problem is the feedback. Domotics, smart home. Alexa, turn on the lights. Nothing happened. We go back, 1 hour later, she turned on the lights. Why? Oh, scheduling on a server. Or missing connection, received packets on a queue. That's correct by your point of view. But I would be crazy. I'm sleeping. I completely forgot of why I asked the stupid stuff of turning on the lights. So, sometimes taking into consideration the rude computer science methods, I scheduled an action and I want to do my best for achieve that scheduling. is not the correct way. Sometimes you have to think in another way that is not necessarily the one that in the UML code you probably have put. Okay? Another point is, this in particular interesting also for us in Zerynth, is power saving. Embedded devices leave off 90% of the time. A thermostat is off or hibernated. It means that there is no way to call to that guy. There is no get, there is no set, there is no remote procedure calling. It is sleeping. So, if you are not able to perform, to actuate something on a connected device, you have to take this into consideration in the conceptual model. You have to design a conceptual model that tells to the user, do not expect to be able to modify instantly the behavior of your device. It means that in my control app, I will, for example, give a feedback that is something like, your request has been scheduled. You can't change the temperature here on the hub until this temperature has been correctly set on the physical device. Because if you go back home and you will find that your house is cold, you will be very frustrated. You have to tell me that you scheduled my request and you will do my best to help me achieving the result, achieve my goal. But you also have to take into consideration what you will do if, as a system, you will not be able to perform my action, my request. Okay, and I conclude. This is how your user sees an IoT product. You are here, he, she is there. You think to the platform design, to the service design, to the production, to the conceptual model. Maybe you think after today to the interoperability, but be careful. At the end of the day, they will push button somewhere, or they will move knob on a physical device. This doesn't mean that you have to take care of only of that stuff. This means that the core is here at the center. The take-home message for today is start from the center. Together, all the things involved in the design should work on the belief of this organism. And then you can go in your development offices for the tech side and on the UE department for the front end, but the core is in the middle. Because here is where your user will evaluate you. Thanks. Question? Cookies?
Question is, since it's so difficult to come up with the right user experience design and so user interface and so everything for the IoT, has been attempted some usage of artificial intelligence to come up with this?
That you are having a layer of uncertainty.
Or artificial stupidity. I mean, I don't like Alexa, and I don't think it solves this problem. But I mean, you have a fridge, you have a washing machine, and you have interfaces, and we are requesting the designers and engineers to come up with a solution that maybe is not there because you don't have a screen, you have a system.
Oh,
Where does
a lot of tentatives of using artificial intelligence for everything has been done.
Yeah.
But the problem I see is that people want to be in control. And people feel happy and they have a pleasurable experience when they have the illusion of control. So I don't think that one day we will leave home, say, hey Alexa, I'm leaving, take care of everything. Probably the advanced user will create routines manually, say turn on the alarm, open the gate, set the temperature, whatever. Because, in a short time future, we want to see this automatic technology in action before going to the next step.
Yeah.
First of all, you have to demonstrate that at least you are able to take care of my heaters. So, in my opinion, I would avoid introducing abstraction and uncertainty layer in the conceptual model, and I will try to bring the Internet of Things into common people, houses, and businesses by designing very simplistic conceptual models. The main problem I see in the IoT UX design is that web design is too advanced for being applied as it is to the connected devices design. Probably we should do some step back and starting something like from the assumption of the 90s websites where download was not necessarily available, data stream was not necessarily available, high bandwidth was not necessarily available, and the buffer, the cache was not for speeding up, but for navigation and stuff like that. I don't know if I answered your question.
Yeah. I was thinking about the Black Mirror episode. The one where they copy the mind of the girl to activate the something like that. Not that.
How do we approach the update of experience that's already radicated in our mind? For example, if ATMs are something that are moving less and less, but old people will still use because they don't have access to, they are not used to use card as much as we do. And my grandpa cannot use touchscreen ATMs. But every ATM in his area has been substituted with touch screens. He had this experience in mind of you using an ATM with buttons, and now he cannot use it. He cannot use it anymore. How strong should be the change and upgrade from one version to another?
Nest, in my opinion, is a very good example of this. 90% of real thermostat uses arrows for increasing or decreasing the temperature. They put the arrows in the mobile app. You have to bring people gently.
I was constraining the freedom of this. You can do like this. In my thermostat, there is 100 knots. I always feel cold because I know
This is an extreme simplification of the system that goes in the direction of reducing the computational effort you have to spend for understanding how to use the system. There is something to be tried. You are turning right for opening hot water, except in UK, I think, but in the rest of the world. So they applied the same conceptual model to the physical nodes. Why? Bringing to the app the same conceptual model that you typically have on the electronic devices. This try to limitate the transition cost. By the way, transition cost is the problem with the capital capital P in innovation in general. My suggestion is to try to not necessarily to stick to the actual conceptual model, but to simplify them. What I mean? We have to stop hard complexity. There is no reason for building a smart device that asks to the user the same mental effort of the previous available technology. If you are smart, it means that you have the brain power that I will save. This means that the conceptual model should be easier than the previous one. In this case, it is. You don't have to program me. You have to tell me if you are feeling cold or hot. That's all. Typical thermostats are super greasy for being programmed. In the case of the ADM and the touchscreen, I don't know how to help you.
It's very interesting because there is no absolute time.
There is no absolute temperature.
And no absolute time. In 25 minutes, this will happen.
In 25 minutes.
Yeah. Not at 3 p.m.
I will reach that temperature.
Yeah.
And if they will be 26, and you will never see 22 minutes. You will see 25 minutes, 30 minutes, 40 minutes, because you don't care. But if I will write 10, 21, it will be crazy. If at the 22nd minutes something will not. This is another typical approach is less is more. Try to reason it the other way. Which is the added value of telling to the user that this temperature will be reached according to our super artificial intelligence algorithm in 23 minutes? Which is? There is no value. It's just you being proud of having developed that algorithm. Okay? This is a stupid lookup table. 2 degree, 20 minutes. 3 degree of delta, 40 minutes, and that's all. And you compile that lookup table, and that's all. Few bytes on a microcontroller. The difference is months of development for frustrating user. We have to avoid inducing the user in challenging the technology. Our technology should always admit of being imperfect, basics, in a learning condition. Telling the user, please be good with me, I am just a beginner of this new world. Vice versa, if you will tell to your user, I am in charge here, I know everything, you will induce the user in testing you, and we will fail as technology.
Is there a branch of user experience and user interface about providing errors
Mitigation strategy.
or of the system? I mean, Windows has the blue screen of that, which is not useful.
There is a branch that is called error perception and error mitigation strategy. First of all, we have to understand what an error is, how errors are perceived and, let's say, internalized by humans according to the human brain, and then there are strategies for avoiding the user in doing error. For example, the lock save before closing pop up. That is called locking. I lock you in the previous action until you express a confirmation of your wish. Another, for example, I think that absolutely doesn't work is the checkbox for the privacy.
Yeah.
Everyone will flag. Don't put a checkbox like, are you sure to want to do a firmware over the air update? Everyone will put that flag at the bottom. If you are doing risky stuff, you have to lock in or lock out. The lockout is, for example, when you go on a website.
It's also sort of a guide, because for example it's a double check operation, and you want to do something, okay, I ask you a confirmation of that.
Yeah, but there is a drawback. That you have to dose the amount of confirmation, feedback, lock in and lock out in a way of avoiding this become automatized action. So if every time you push a button you receive a pop-up, you will accept all the pop-ups that are available in that interface. So they become useless.
There is a nice interface for this kind of thing. For example, when you want to do very risky stuff or deleting a repository or deleting a resource on AWS, there is not only the pop-up, but you have to write the name of the project that you want to do. Are you sure? If you are, write it.
Yeah. Another trick for avoiding error, for example, is to use the mapping, but in the opposite way. Have a not facilitated mapping. For example, if in order to do a dangerous action, you have to push two buttons, these two buttons have to be put at the side of the screen. Because you have a mental effort that is
You have more time to be.
either to bring from one
Usually
side.
the dangerous action, you have to scroll to find it.
Yeah,
That's the first one that you see is.
that's the error management strategy.
In the last slide, you show this flow. But is it acceptable to have more than one conceptual model for different users starting from the same service?
No.
It's not acceptable.
No, the conceptual model represents the functionality of the system. It's only one. And your challenge is to having this internalized in different users starting from a different knowledge base. The challenge is create the same mental model in user belonging to different culture by starting from the same conceptual model. If you are not able to do this, you have to simplify the conceptual model. There is an exception to this, and is when the system gives you more functionality while using beginner, medium user, and advanced user. But the conceptual model is the same.
Indeed, I was thinking about different users of a platform, so developers, users can have more sophisticated API or something related to the conceptual model, but a way to go more deeper to interact with the system and the end user. So the conceptual model can be also requested by different.
But the conceptual, you have to think to the conceptual model like a layered structure. Okay, the basic, the fundamentals. I mean, you can add layers of complexity, but you can't change the conceptual model. If you want to change the conceptual model, you have to develop two products, or at least two control interfaces. Like the conceptual model of an installer technician that will install an IoT product could be different by the conceptual model of the final user. But these two personas will have two interfaces that maybe share some pages. But
there are two use cases, but one product. The product is the platform, for example. And then the platform has its roles, its users, its personas, and then each persona has its use cases, use flow to use the platform.
But the conceptual model is only one and can be layered with different level of complexity. So do not disclose some advanced feature to, like in Windows, hidden files and folders are not shown on the file explorer until you check that specific stuff because of a reason. the concept of hidden file is not necessary for 80% of the user. But the model is the same. A file represented as a set of bits represented as a file.
Are there any advances in the conceptual model we are used to, for example, desktop conceptual model?
No.
Not
There is a tentative, very interesting. I will show you. I don't remember the name of the operating system, but it's all from PhD student of design schools in US, because the Windows model is still not Windows the software.
Yeah.
The Windows.
I'm thinking about programming, because it's what we do, and I find very frustrating the fact that you have to write program in files, because you are writing functions. They should go, and you have to search the function in files.
Cloud system like Azure function,
Yeah.
Button function probably are trying to go toward the direction, but with the results that
but-
according to the model we have, debugging the stuff
But
becomes
I don't have a user interface for serverless programming,
clear.
so that's what I'm.
And at the end of the day, you are still representing the Lambda function as files
Yeah.
that contain a piece of code.
Then, what was the idea of the other Lambda function that I update, and it's the same file.
Thanks to the peer-to-peer.
Yeah.
We invented a way to have distributed file system, but at the end of the day, we are exchanging files.
Okay.
Okay, thank you guys.